Okay, and I think we are good to go. I wish you a very nice evening here at Techorama. My name is Stropek, and I'm glad that you are here for 1 hour Records Inside Out. This is the Techorama website, and I do not have any slides for you. This will be a code-only session. I will not type so much code, but I've prepared a lot of code. And we will dissect records, record classes, and record struct to a large degree. So if you would like to get in touch with me or keep in touch with me, you can always use my digital business card, which you can find exactly under that address. And on the right lower corner, you see a bunch of social media links, and you can use LinkedIn, Facebook, Twitter, whatever you prefer to ask questions. I'm always open for direct messages, so if you have any problems or questions after this talk regarding this topic or anything else regarding .NET or C#, feel free to send me a message. The last thing that I would like to mention before I go right into the topic is this one. As this is a code-only session, I have prepared, as I said, a lot of code, and you might want to take a look at this code after the session. I'm trying to record this session. If everything works out nicely, then I will put the recording on my YouTube channel. But if it doesn't work out, maybe it will not appear on my YouTube channel, and then it is maybe a good idea to take out your phone, take a picture of this URL, because this is the GitHub repository where you can find all the code snippets that you are going to see in the upcoming hour. I'll keep it on the screen for a second for you to make a photo. Okay, and with that, we will dive right into it. Let's get started. I have prepared a sample solution with 7 chapters, and we will work our way through these 7 chapters. The first one, the basics area, is for those of you who have maybe used records, not so much, or maybe a little bit, but you're not so sure why and what's the difference. So this will be the basics. And once we cover the basics, we will work our way up to more elaborate solution scenarios. Let's get started with this very first little class. Let me zoom in a little bit, and I hope you can read it even from the back. Here I have created a class which I called Hero Naive. It implements a very simple data record class. Nothing special, just a class, as you can see it here, and it has an empty constructor, empty properties, getter and setter, nothing special. Let's start from here. Obviously, we can, let me zoom in, use this class in the usual way. We can create it, we can manipulate it. The class is mutable. The question is, do we want that? But currently, it is mutable, and we can use, as you can see it here, initializers. So we can initialize the properties as usual. One big disadvantage is that with this kind of implementation, you see it up here, we cannot enforce the user to really set these properties. So we have setters, everybody can set it, we can set it, everybody outside can set it. It has a lot of drawbacks. This is why I called it a naive class. I see those classes all over the place. I bet you have written thousands of them. You do it all every single day, but it is not optimal. Let's try to make this class better and see how records can help us with that. First, I would like to add a constructor. See, this is the kind of code that you write in many, many cases. You write a constructor where you put various variables here, parameters in the constructor, and then you assign these constructor parameters to the properties. See, here I'm using the tuple assignment. Take a look at that one. Maybe not all of you are familiar with this syntax. This is a tuple assignment. So the first parameter on the right-hand side is assigned to the first property on the left-hand side, and so on and so on. I think you get the idea. But you know what? Writing such constructors is really tedious. That's toil that I don't want to be responsible for. I really don't want to write such constructors, but without records, you definitely have to write them. I write a lot of code in TypeScript too, and there it's much easier. So we will see records will solve this problem. That's the first one. I mean, using it is very, very simple. We can use the constructor, pass in some parameters. Well, nothing special here. I have consciously removed the public setters here, so this thing is now immutable. I cannot mutate the state of this class, because everything is stored in read-only properties, and all data types are immutable too, because I use strings, and strings are immutable, as you all know. So this is now an immutable class. Sometimes this is super useful, sometimes this is not what you want, but hey, I built it like that. Let's keep it in mind. We are working our way down to the records. Now, wouldn't it be nice if we could compare two heroes? You have that often. You have a business object, you have another business object, maybe one came in through a web API, the other one came out of the database, and you simply want to find out, do they contain the same data? In this case, as many of you will probably know, you have to implement an interface like Immutable. Immutable, in this case, is an extension to our naive class, and now it's getting more interesting, because now we have, let me zoom in a little bit so you can really see it well, we have the equals method. To be more specific, we have two equal methods. One is typed, the other one is untyped, and we have to implement that in order to not do a reference comparison, but a comparison using content. In addition to that, if we can compare the content of the class, it also makes sense to implement the getHashCode method. And luckily, current versions of .NET offer us a class which is called hashcode, and there is a method which is called combine, which makes it very simple for us to simply combine the hashcodes of all our properties into a new hashcode. So if I quickly want to find out if two objects are possibly equal, I can simply calculate the hashcode with the getHashCode method. It's very simple to implement, but still I have to do it. There is another slight addition that I sneaked in. Oops, sorry, I typed something which I sneaked in a little addition which many of you might know, but maybe not all of you. These are so-called init properties. If you specify init properties, then the caller of this object, the user of this object, can specify a value for this property when creating the object in an object initializer expression. And note in this case that I combine the init-only properties with default values in the constructor, as you can see it here. That gives us the possibility to construct an object using the constructor, and we can also construct the object using property initializer syntax. Very nice. We can use both. So I switched from non-existing setters, which make the class immutable, to initializers. The class is still immutable, but I can use initializers. If you don't use the init keyword in that area, you simply cannot use initializers. You only can use the constructor. Okay, fine. Yeah? Now we know what initializers or init-only properties are. We are still not there, because if we can compare heroes and we can initialize heroes, wouldn't it be also nice to be able to clone a hero? To clone an object, maybe because we want to give it back from a function that doesn't want to share its internal state? Of course, we have all the properties of before, but now I added a clone function. You see? It just takes this and makes a clone by calling the constructor. Nothing special. But still, we had to write it. Kind of tedious, right? Last but not least, before we finally reach our goal and we can finally use records, deconstruction. I'm not sure how many of you are using deconstructors in C# on a regular basis. I find them super, super useful. Let me show you how this works. What you essentially do, you add a deconstruct method, you see it here, which has for each property an out parameter. Here you see the out parameters, and you have, very similar to the constructor, an assignment. In this case, again, I use the tuple assignment syntax because I only have 3 properties, and it fits nicely into this tuple syntax. Okay? Once you build this deconstruct function, don't mix it up with a destructor. That's not a destructor, that's a deconstructor. Yes, in C# we have constructors, finalizers, and deconstructors. A little bit confusing, granted, but it is like it is. The syntax which will be enabled is this one. So we can simply take our hero and deconstruct the content of the hero into 3 different variables. In this case, name, can fly, and the thing in the middle, the universe, is ignored. For that case, we are using the underscore operator, which just says ignore this property in the middle. So if you take a look at this class, it has gone a pretty far way from being a very naive class with an empty constructor and 3 properties to a class that implements Immutable, that is init only, that can be cloned, that can be compared. That's a lot of work. Enter records. I always call this Harry Potter programming. A little bit of fairy dust and it magically works. And this is exactly the entire code that I need to achieve exactly the same as you have seen in the past few minutes with a single line, and that is records. So if somebody asks you, hey, what is a record? You're using a record. Why are you using a record and not a class? In fact, the answer is, I'm using a class, because a record is just a class. But it is syntactic sugar where the C# compiler generates a lot of stuff into your regular class. It generates a constructor. It generates properties, which are init only. It assigns the values to the properties automatically. You don't need to do anything for that. It implements Immutable, so you can compare these objects based on their values, not on their identity. It implements get hash code. These things can be cloned and even manipulated, as you will see in a second. These things are immutable. They are unchangeable. Once you created it, they cannot be changed anymore. So all the properties of this class that we have defined in the last few minutes are there for records. But it is a single line compared to dozens of lines that you would have to write if you would do all these things yourself. So this is what records essentially are. They are classes, full stop, with a little bit of fairy dust and Harry Potter magic to do a lot of additional functionality. So how can we work with these records? You can see, I use the constructor, works. I use it without the constructor, but with the init only property, works. Deconstruction, works. We don't need to write code for that. This, let me zoom in a little bit, because maybe not all of you know this syntax already. This is cloning a record, and in the process of cloning, we are changing a single property. In this case, we change the hero's name to Stormfront. We can also use this thing in collection initializers. So in this case, I am creating a new array of heroes, as you can see. Then I'm creating the hero here with the constructor. And interestingly, I don't know if you have ever seen the syntax, you can assign this thing to a temporary variable and use this temporary variable immediately in the next line and use the with keyword in order to clone this object and change a single property. So I copy it and change it a little bit to insert it immediately into the same collection. So you see, the syntax variants that records give you are pretty powerful. Value-based equality works also fine. We can create 2 different heroes, this one, and we can compare them and we are still the same. And here, unfortunately, is one of the largest drawbacks of record classes. They are immutable. Yes, that's a good thing. In many situations, that is exactly what you would like to have. Because immutable classes are thread safe. That's good. But have you ever tried to do data binding against an immutable class? It doesn't work so good. If you write some WPF code and you want to do some data binding, unfortunately, it doesn't turn out very well. Have you ever tried entity framework with immutable data classes, it doesn't really work well because you simply cannot update data, and in many cases you want to do exactly that. With record classes, you have no opt-out mechanism with which you can say, I would like to opt out from immutability, I would like to have mutable classes. It's simply not there. We will see a little bit later on that this is completely different with record structs. But hey, I'm getting in front of myself, so let's close this basics. Now we know why records are there. Let me quickly repeat that consciously. Records are classes with syntactic sugar that just generate a bunch of code so we don't have to write it. That is what record is all about. Nothing magic. Nothing fundamental changed in the common language runtime. It's just code generation. Next one. Are records always trivial? No, they don't need to be so trivial. Now it's getting more interesting. Let me make the screen a little bit larger and let me point your attention to exactly that interface. This interface is called IAmHero and consists of two properties, name and universe. And look at that one. Here we have another record, hero, but this time I'm deriving from an interface. Yes, that's possible. You can definitely use interfaces, continue to use interfaces with records. And see, here we have read-only properties, and we don't need to do anything with the record. It automatically is compatible with the interface because, as I told you, it's just a code generator. Records are classes with auto-generated code, so implementing interface, thumbs up, works perfectly fine. And as you can see, here, proof. This is the unit test. IAmHero equals new hero, compatible, no syntax error. C# compiler is happy. I am happy. Interface implementation works. Now, can we inherit records from other records? Remember, we had the hero record before. And here, I'm using another record, and I would like to draw your attention to this here. Here you see two records which inherit from each other. So you have a base record and you have a derived record. That works perfectly fine. You also see that at the end of the record we can add curly braces, and then if you want, without any problems, you can here add additional properties and functions to your record. So records do not need to consist just of properties. You can add as many functions, behavior, as much as you want. You can even add, as I said, additional properties. They don't need to be in the constructor. If you want, add whatever you want. You can even override toString, for instance, in order to, in this case, print the full name. Now, this inheritance is not so beautiful because what you have to do, let me show you that, you have to take all these properties that you get in the derived class in the constructor and you have to pass it on to the underlying, to your base record if you want. And you have to do that manually. So if you have a large record consisting of, let's say, I don't know, 25 properties, then you have a constructor with 25 parameters. And if you want to pass on 24 of them to a base record, you have to manually do that. That's not beautiful, but it is like it is. Don't shoot the messenger. Maybe we will get something additional in the future, but currently it is like it is. Yes, inheritance is supported, but you have to pass through all the properties in the constructor of the base class, base record in this case. By the way, small comment, we will need that later on. The full syntax, I've not shown you the full syntax yet, because the full syntax would be public record class. You can leave out this class thing, then it is automatically a record class, but you can write class if you want to make it very, very clear for the reader of the source code that this is a reference type and not a value type. If you want to have a value type, you have to use record structs, and you will see that in a few minutes, okay? So, you see, we can derive from interfaces and we can derive from other records. obviously there is one big question in the room, right? Can we derive records from classes? Can we derive classes from records? Unfortunately not. So this is not possible. The C# compiler does not support that. You have to derive records from records and classes from classes. It's not possible to mix these two things. Okay, you see, the constructs are getting more and more interesting. I mentioned it already, but I would really like to draw your attention again on this thing here, because it's not so obvious. You see, we have a real-life hero, and this real-life hero has a characteristic property, an additional property. See, this one, Superman, is characterized by his classes. That's the property. And please note that this property is an optional string and has a get and an init function. Now, let's build this thing. I built this application. It should be done. Yeah, it's already done. Let's open it up in File Explorer. Here it is. Let's go to bin, debug, net6, and somewhere here we should have the records inside out DLL. Let's copy this path, go to dnspy. I will zoom in a second, okay? Open this DLL. Here it is. Here is the DLL. Let me look up live, the correct one, and I think it should be somewhere here. Where is it? Yeah, here it is. And I'm looking for the real-life hero, and it's in inheritance and members. Good. So inheritance and members, and here we should have the real-life hero. Here it is. And let's switch to C#. So we have a decompiler, and see, this is what was created from our record. As promised, this is a class. This is a class that inherits from the other hero. So you see, just a usual class. I told you that before, but now I prove it to you. And it automatically implements IEquatable. And please keep that in mind, IEquatable. Let's scroll down a little bit and look for equal, equal, equal. Here it is. Here is the equal thing. And where is it? Yeah, this one. This is the auto-generated equals method. And there is one tiny, teeny thing inside of this implementation which you might not expect. And that's this one. See? So, although this characteristic property that we created here as an additional property in the record, it is not part of the record's constructor signature. Although we added the additional property, the code generator recognized it and takes it into account when generating methods like clone and IEquality and things like that. So adding additional property works perfectly fine. This is exactly what this thing is thought to do. So you can do that, and you don't need to worry that records will mess up your code. It will not. It will recognize that, and it will work fine. So additional properties are more intelligent than you might have assumed. Yeah, the rest is just methods, nothing special here. Okay, here you see some unit tests, and I think we are good with that one. Yep, close that one up. Now, before we move on to the next thing, I would like to quickly remind you of a category of collections which many of you might have heard of, but you might not use them on a daily basis, but they fit perfectly in the universe of record classes. I told you that record classes are immutable classes. So once you created them, you cannot alter their internal state. And good friends of immutable record classes are immutable collections. Maybe you haven't heard of them. Immutable collections are collections where you cannot change the content. That doesn't sound to be very useful, right? I mean, if I have an immutable empty list, by design, I cannot mutate it, therefore I cannot add anything to an immutable list. And if it's empty, and if I cannot change it, it will always remain empty, right? Luckily, there is a trick. You can start with an empty collection, and you can call a method add, but this method add does not add something to the original immutable collection, but it returns a new immutable collection. It leaves the original one alone, but gives you a new one, in this case with a new element, as you can see it here. And now you get something pretty powerful. Now you have an immutable record, which is an immutable class, and you can put it into an immutable array, for instance. And at the end, you can see the length, you can do some link on top of it, and the beauty of immutable data structure is that it's thread safe. You don't need to lock this thing if you do some heavy calculation on top of immutable data structures. Because you can absolutely be sure, if somebody gives you an immutable array with immutable record classes, that the whole data structure is immutable. Nobody can change it beneath your feet. That's not possible. So if you do multi-threaded programming, immutable collections in combination with records are definitely your friend. I would love to have not just immutable collections, but maybe something like freezable collections, where I can add something for a certain amount of time and then freeze them once I start to process them parallelly. That is unfortunately today not supported. Well, there are community projects, it's not so hard to build something like this, but at the end of the day, it's not built in. What I would like you to take away from this demo is a quick reminder that you have these immutable collections in the .NET framework. So use them, they are useful, especially when it comes to parallel programming. Good, nice. Inheritance and members, chapter 2, check. Next chapter, record structs. This is an extension that came recently to C#. This is the newest family member in the area of the records. The biggest difference compared to the record classes is obviously the keyword struct, but the behavior. Record structs have value semantics and not reference semantics, just like structs and classes. Let me quickly remind you, for those in the audience who have not so much deep dive knowledge in C#. C# has two different types of objects. One are the reference, reference objects, and the other ones are the value types. Reference types and value types. Classes are reference type. If you copy a class, if you just assign something, then you essentially are just assigning the reference. If you copy a value type, if you, for instance, assign a value type to another variable, you make a copy. This is what we call value semantics. And record structs have value semantics. Everything else, what I told you about record classes, apply nearly equally to record structs. IEquatable, check. Get hash code, check. Constructor, check. Property generation, check. All these things are just there. So if you know record classes, you know a big deal about record structs too. But sometimes you want to have a struct. And I will show you examples for that. Generally, personally, I think that .NET developers underuse the stack. We tend to put everything on the heap because in the past we have maybe learned that the stack is very limited. Yes, it is to a certain degree, but the stack has a huge advantage in comparison to the heap. You don't need a garbage collector to clean it up. It is cleaned up automatically. So if you put lots of small things on the stack, then you reduce the pressure on the garbage collector, and that is very good. Microsoft invented the record classes first, and my heart was a little bit bleeding because I personally thought, hey, classes are nice, but writing a real good struct is really a pain. And now structs have become way easier by just saying record struct, and you get all the best practices for structs for free. So as you can see, you have constructor, properties, all there, and of course you can add additional methods, properties, and things like that In this case, I'm adding a method which I call translate. I want to translate a vector by just adding a dx and a dy value. And this simple method translate shows you a very important distinction between record classes and record structs. Remember, record structs are by default not immutable. Isn't that strange? I mean, over years we have learned that if you build a struct in C#, it is best practice to make it immutable. And now they invent structs, record structs, and what do? They make them optionally immutable. Because what you can do, let me go down a little bit, you can add the additional keyword read-only to the record struct to turn the struct into an immutable struct. So you have the choice. By default, it's mutable. By adding read-only, you make it immutable. I, personally, nearly always use the read-only keyword together with record structs. But that's just me. If you have a different use case, feel free to use it without read-only. I think Microsoft just did that because the read-only keyword for structs was already there. Maybe you don't know that, but you could create read-only structs in C# for many versions. That is a rather old feature of C#, and it was simply there. And so they used it for read-only structs. For classes, there wasn't such a keyword. It hasn't been possible to create a read-only class, and therefore they don't give you the option. Okay, so remember that. Record structs mutable by default. Now you can do interesting stuff once you have a struct, and let me quickly remind you. We can easily copy structs by simply assigning them. That's not possible with the record class, obviously, because it's a reference type. The more interesting thing is the keyword stack alloc. I hope you all know it. If you don't, remember it. That's not unsafe C#. That's plain C#. That's possible. That has been possible for quite a while. You can simply take an array. On the left-hand side, you have to use the type span, and then you can allocate an array of value types on the stack and not in the heap. But this is only possible because our vector is now a record struct and not a record class. So yes, big enabler, record struct together with stack alloc, nice thing, isn't it? In this case, we are allocating a small array of records and they are no work for the garbage collector. Great thing. So value semantics, check. Optional immutability, check. If you write read-only, this is no longer possible. If something is read-only, it's also not possible to mutate the state internally. So remember the translate method that we had before. Here, we manipulate our internal state in a method. If I take this guy here, and I put it down here inside of the record struct, remove that one, then we will get an error, hopefully. Come on, yeah, here it is. See, we get an error because we cannot change the state of the struct. It's not just immutable from outside, it's also immutable from inside. It's not possible. So if we would like to implement a method like translate, as you see it here, we need to change the method signature. We need to create a clone of our record struct, and that is possible. I showed you that with record classes. Why shouldn't it be possible with record structs? It's perfectly fine. And we can use the with keyword in order to make changes to the clone during the cloning process. And then we simply return a new instance of the changed record struct. Good? So this is what you can do with read-only record structs. Hash codes are also there, obviously. So that means if you create a new object and call getHashCode, and if you create a different instance of immutable vector, but it happens to have the same content, the hash codes will be the same, guaranteed. The implementation makes sure that if two record structs contain the same content, the hash code is the same. And that enables a lot of interesting use cases. For instance, we can use, let me make that one a little bit larger, here it is, we can use a record struct without any problems as a key inside of a dictionary, for instance. In this case, I'm creating a dictionary of interesting locations where I use the immutable vector as the key in the dictionary. But please, 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 listen closely. If you do something like that, always make your struct immutable. Otherwise, bad things happen. Because what could happen? The dictionary uses the get hash code, or the hash set, or let's say the hash set. Maybe dictionary is not a good idea. Let's say this is a hash set, okay? This is a better thing. I would like to describe it with the hash set because it's more obvious. What do we have? Hash map, of course. Dictionary. Let's stay with the dictionary. In the morning, I did a talk about Rust. And in my mind, I just switched Rust with C#, because in Rust it's called the hash set, the hash map, and in C# it's called the dictionary. I'm very sorry for this mistake. So let's stick with the dictionary. The dictionary takes the hash code in order to put the data in certain buckets, okay? And what happens? It takes the hash code, and if you change the state of the thing is not moving magically into a new bucket. The hash code is not re-evaluated. Therefore, very important, make your structs, your record structs, immutable. And I told you how that works. Just write read only in front of the record struct and you are fine. Okay? And then you can use it as a dictionary key based on the hash code. Nice. So, chapter 3, record structs, value semantics, immutability, hash codes, check. Breathe in, breathe out. Next topic. JSON support. Yes, JSON support is there. Obviously, you can call JSON serializer.serialize and it will just work. Thumbs up. This is what we expected. But how can we influence the serialization of our auto-generated properties? And this is the magic sauce here. See it? So if you would like to manipulate the properties that are auto-generated by record structs or record classes, you need to be able to assign some attributes on the generated properties, but you don't see the generated properties. Well, you might expect that we need to do something like this, but this is in fact not absolutely necessary. What you can do is you can use this syntax here, where you tell C# that this property, for instance the JSON property name property, attribute in this case, should be applied to the generated property, not to the constructor parameter. Yeah? If I would remove this property here, I would get an error. Let me show you that. If I hover over, and let me see if I can zoom in. Yes, see? Here, take a look at this error here. Attribute JSON property name is not valid on this declaration type. It's only valid on property indexer field. But we want to apply it to a property. And in order to tell C# that, use the property colon syntax. Okay? No need to build a custom property here. And then everything works just as expected. You can create your heroes, you can call serialize, and it will simply work. And it works the other way around too. You can call deserialize, and the JSON deserializer can, without any problems, recognize the constructor and pass the values for the serialization into the constructor parameters. Will just work. Okay. Chapter 4 was a short one. Check. Chapter 5. From classes and back. I called it from classes and back. Let's take a look at the setup here. I created, again, our good friend, the hero, consisting of a hero name, the universe, could be Marvel, could be DC, could be your favorite universe of superheroes, and a property can fly. And then, down here, we have a class, traditional hero. Something like this might happen to you. Imagine you use Entity Framework. Your data classes for Entity Framework are classes. What else would you use? Is it a good idea to use records for entity framework? I already told you, I spoiled it. No, it's not a good idea, and I will show you the code in a second, okay? It's not a good idea to do that. But at the end of the day, you have a data class for entity framework. Now you have a DTO, a data transfer object, in your web API, for instance, and it turns out, I will also show you that in a second, records are great as DTOs with ASP.NET Core. So how do you transfer your entity framework data into your DTOs? Well, you can write a lot of manual code and copy each single property, or you use a library. A library like Automapper. Anybody Automapper in the audience? I guess you use, yes, a lot of hands going up. Exactly, use Automapper. Now, it's super important to understand that records are just classes. So we have a class here, we have a class here, so why shouldn't we simply use Automapper for that? And the answer is, it just works. I added Automapper to this project here, and you see here, we have a hero called Homelander, and here we have a traditional hero called Homelander. I don't know if you know the TV series, The Boys. I like it, and therefore I use the demo data from there. And see, I can use the mapper configuration, and this is from the Automapper NuGet package. And I just create a map. In this case, I make it very, very simple. Those of you who use Automapper on a regular basis, you probably know how to configure all this stuff. It's just important to understand that the construction of objects must happen through the constructor. So you might need to add a little bit of magic to Automapper to make Automapper use the constructor function and not just the properties. And then you can simply map the record to the class, or the other way around, the class to the record, and it will just work. Behind the scenes, both are just classes, it just works. So this is really a nice application of records. Again, entity framework, data classes, you get them from the database. They are mutable, just as you like them. Or maybe MVVMs, model view view model, if you build .pf or I don't know, WinForm stuff with data binding. You have your MVVM data classes and you would like to transfer them into data transfer objects or something like this, then this is super important. So, good news, because it is just classes, it just works. Chapter 5, from classes and back, Automapper, check. Now, I would like to show you a thing that doesn't work well. I'm a big fan of records, but in some areas, records shouldn't simply be used. And the example scenario that I'm going to show you here is a typical scenario about that. It's together with Entity Framework. I mentioned it already, but let's think it through so we really understand why it's not a good idea to use records with a thing like Entity Framework. Now, as you can see here, we have our traditional hero here again, and it's a record class in this case. So I would like to see how far we come when we use a record with Entity Framework. Here, you see the hero context, a traditional Entity Framework database context. We have the constructor, nothing special here. And here we have the DB set, and yes, it is possible to use the record as the DB set type parameter. This works. Entity Framework does not complain, works perfectly fine. Now here I'm using for demo purposes an in-memory database. This would work with SQL Server 2 or any other database that you like, but for demo purposes, because this is not an Entity Framework talk, I will just stick with the in-memory database. Good. Now let's see how it works. We are creating the database context, we are creating a hero, and see, we add the hero and we simply call save changes async. And believe it or not, it works. Absolutely no problem. We can expect it to work, right? It's a class behind the scenes, so why shouldn't it work? Check, does work. The interesting thing is, this one also works, but this is strange. What did I tell you? Record classes are classes, and they are immutable, right? But in this case, the database table contains an auto value. So the primary key is generated in the database, and what we typically expect from Entity Framework is that it automatically translates the new primary key into the ID property in this case, right? But it can't do that because it's immutable, right? But Entity Framework can do it. Because at the end of the day, they are just using, I assume, reflection in the background to do some magic, and they simply don't care about whether this thing is immutable or not. They simply write the ID into the object. So we have an immutable thing which is not really immutable if you are Entity Framework. Yeah? So Entity Framework is a magician. They can go through walls without any problem. Yeah, it's just behind the scenes, it's a class, and they just use reflection, and they're not all rules of physics apply. Yeah? So no, you shouldn't do that. That's not as intended. It just is like it is. Now, what is if we want to update this thing? And now it gets really ugly. Because what we could do is we could detach the object that we read from the database, then make a clone of the object and change a property. In this case, we change Homelander to Stormfront, and then we can really call update and save async. But that works. It really works. It updates the database. But is that beautiful code? Absolutely not. If you would like to update something, it's natural that you would like to update a thing, so a mutable class is not a good idea. Querying, on the other hand, works really nice. So if you have a database and you are a read-only, maybe data science application, hey, feel free to party on with records. No problem, because this stuff works perfectly fine. So if you have some read-only stuff, do it. It works. No problem. Okay? So, light and shadow. We will see how things go with records and Entity Framework in the future. We will see whether we will get something magically, but currently simply use classes. And from this talk, I would like you to take away, okay, let's stick with classes with Entity Framework, but we now know that we can use Automapper whenever we have to translate this thing into a record. And that leads us, in the last few minutes, we'll use another 5 minutes or so, and then we have 5 minutes time for Q&A. That leads us to the last chapter. And that is this one. It's called Record ASP.NET Core. And if you ask me, this is the sweet spot for records. At least this is the area where I use records all the time. Let me show you this small little API. This is a minimal API. This is ASP.NET Core 6. This is a minimal API, no controllers here. Exactly the same code would work inside of controllers. No problem at all. Now let's take a look at it. Because ASP.NET Core is a multi-threaded system, we are using a concurrent dictionary here. Using a list would not be a good idea because list is not thread safe. A concurrent dictionary is definitely a good idea because it is thread safe. By the way, I always try to sneak in some really nice syntax constructs of C# which are not so well known, at least in my experience when I do workshops with customers. Many don't know the new dictionary. It's not new, it's not super new, but it's rather new. The new dictionary initializer syntax. What you can do, you can use here the dictionary key directly in the initializer. Works pretty well, and it does not just work with the dictionary, it also works with a concurrent dictionary. Okay? So in this case, I'm just creating some demo data. Now, hero, this one, let's look into hero, and you will see that hero is a record. So in this case, I'm using a record, but if this would be Entity Framework, I would use a class. I told you that already. Now, querying some heroes, no problem. I don't have to talk about it. Querying a specific hero, no question, works just fine. We use the try get value, store the optional hero here in this h variable, use a switch expression, and turn false into not found and true into HTTP 200 OK and return the hero. And because of the support for JSON serializer, that works. What happens behind the scenes? It gets the hero, which is immutable, out of the concurrent dictionary, translate it into JSON, and turn it into HTTP response with status code 200 and JSON serialized hero data. Records. Magic of records. They work. Great. But now comes the interesting thing. I have implemented a post here. And in this case, I would like to use a data transfer object. I would like to use, granted, this is a very simple example, but I think you get the point. This is the data transfer object, which is not identical to the data container object hero. I called it new hero DTO, and for the sake of simplicity, I simply left out the ID, because the ID is not passed in when you would like to use the API for creating a hero. The ID is generated by the server, in real world by the database, right? So what I did is I used a DTO object, a record class, and used the record class here directly in the method's body. So the HTTP response body is deserialized into the DTO, and I get the new hero DTO. And that works perfectly fine with minimal API, and it works perfectly fine with controllers. Now, inside of this method, I can, here, manually convert the DTO record into the data record, or I could use Automapper to translate this stuff, for instance, into an entity framework data object. Well, the rest is history. I look up, in this case, because I'm in memory, I'm looking up the maximum ID, add new ID, whatever, try to add it, it's fine, and I return created at route, and that's it. So this is the point that I wanted to show you. If you have lots of APIs, records shine as DTOs. And with that, time flies, we are nearly at the end. Let's summarize. Let's summarize by going back to the basics here. Remember what I showed you at the beginning of this session. I showed you a hero class which was really, really naive. It just contained an empty constructor with some getter-setter properties. And then we worked our way up by adding lots and lots of code. And at one point in the demo, we had, let me zoom out a little bit, we had a large class here. And that's the point. If you want to convince your colleagues to use records, show them this picture compared to this here. That's essentially the same. And then, for the rest of the talk, we dived in. I showed you inheritance, interface implementation, deconstruction. We worked our way through samples where I showed you where it works and where it doesn't work. And this is what I had for you today. And we have a few minutes left, 5 minutes or so, for Q&A. Before we go into Q&A, thank you very much for coming. Thank you for visiting Techorama. I had a blast, as every year. This was my second and last session here at Techorama. I wish you a beautiful rest of the conference. And with that, I would like to say again, thank you, and open it up for questions.